It's week 13 of 2022. This is Talkin Science. Gilmour Space awarded a $52 million grant to boost space manufacturing. New evidence suggesting research stations are big polluters. And cracking the solar wind secret. Just how does the sun get hotter the further away you get?
This is Trekzone's Talkin Science.
A Trekzone membership is available via the join button under each video on YouTube or via the trek.zone/support. Plus Trekzone's on Twitter, Facebook, Instagram, and your favourite podcast feed. Find us, like, follow and subscribe. Welcome to Talkin Science. I'm Matt Miller. Let's dive in. Gilmour Space Technologies and the Australian Space Manufacturing Network has been awarded a $52 million grant to help fund manufacturing facilities and the Bowen Orbital Spaceport. The Modern Manufacturing Initiative Collaboration is a federal grant program that aims to promote collaboration across 6 different industries, including space. Under the initiative, the collaborative stream provides funding for a small number of large transformational projects. The MMIC grant will be used by Gilmour Space and the ASMN to support the development of an advanced manufacturing facility for building satellites and rockets in Australia, and a common use testing and manufacturing facility to provide framework and infrastructure for collaboration within the space industry. The grant will also be used to co-fund a portion of the proposed Bowen Orbital Spaceport at Abbott Point. Gilmour Space CEO and friend of the show, Adam Gilmour, said details have yet to be provided, but we and our ASMN partners intend to leverage this grant to engage the full spectrum of space activities, from research and development to advanced manufacturing and launch. These efforts will help grow the industry and deliver real civil, commercial and defence benefits for the nation. Space and ground research facilities are the largest contributors to the carbon footprint, according to a new study by an international team of researchers. The climate impact of astronomical research has been discussed in recent years, with the carbon footprint associated with astronomical research activities, such as flights to academic conferences or running supercomputer simulations, emerging as major sources of carbon emissions. Following a method developed by the French Agency for Ecological Transition and the French Association Bilan Carbone, the authors reveal that worldwide active astronomical research facilities have a total carbon footprint equivalent to approximately 20.3 million tonnes of CO2 and an annual emissions equivalent to around 1.2 million tonnes of CO2. This annual figure is approximately 5 times larger than estimates for work-related flying, with space-based missions responsible for at least a third of total emissions. The authors note that they adopted an uncertainty rate of 80% for the carbon footprint estimate of individual facilities throughout the study. Odd radio circles are so faint, rare and far away that it takes the world's most advanced radio telescopes to find and describe them. First discovered by CSIRO's ASCAP radio telescope in Western Australia, the Meerkat radio telescope in South Africa is now peering deep inside the heart of ORCs. This new detailed image captured by Meerkat is providing researchers with more information to help narrow down theories about odd radio circles. There are now 3 leading theories to explain what causes ORCs. They could be the remnant of a huge explosion at the centre of their host galaxy, like the merger of 2 supermassive black holes. They could be powerful jets of energetic particles spewing out of the galaxy's centre, or they might be the result of starburst termination shock from the production of stars in the galaxy. To date, ORCs have only been detected using radio telescopes, with no signs of them when researchers have looked using optical, infrared or X-ray telescopes. Now, by aging almost 250,000 stars, a team of German researchers believe they've figured out how our galaxy was formed. Because of the short lifetime of these evolutionary phase stars, observations in the subgiant phase are relatively rare, and large surveys have not been available in the past. But the research team believe they've cracked it using data from the ESA Gilmour Space Observatory and Large Sky Area Multi-Object Fiber Spectroscopic Telescope in China to identify around 250,000 stars in their subgiant phase, which covers a large spatial volume of the Milky Way. A series of evolutionary phases is the current thinking, all beginning with the formation of disk stellar populations around 13 billion years ago. Stars in their subgiant evolutionary phases offer a precise stellar clock, as astronomers can directly and precisely measure their age during their brief stellar phase based on their brightness. The age, composition and motion of these stars highlight the dynamic processes involved in the formation of our galaxy, according to the research team. And as more data for larger samples of stars in the Milky Way become available, our understanding of how our galaxy formed will only improve. Well, an international team led by New Zealand scientists has made a breakthrough in learning how magnetic fields play a part in heating up solar wind using six-dimensional supercomputer simulations. Study lead Dr. Jonathan Squire of the Department of Physics at the University of Otago says the surface of the sun starts at 6,000 degrees Celsius, but over a short distance of only a few hundred kilometres, it suddenly heats up to more than 1,000,000 degrees, becoming its atmosphere or corona. Dr. Squire and co-author Dr. Roman Mayrand have been working with scientists at Princeton University and the University of Oxford and found two previous theories can be merged into one to solve a key piece of the problem with the group's findings recently published in Nature Astronomy. Effects which result from solar wind's interaction with the Earth's magnetic field is called space weather, which causes everything from aurora to satellite-destroying radiation and geomagnetic currents, which can damage the power grid. All of this is sourced fundamentally by the corona and its heating of magnetic fields. So as well as being interesting for our general understanding of the solar system, the solar corona's dynamics can have profound impacts here on Earth, Dr. Squire said. Well, Dr. Brad's back next week for our monthly wrap of the science and space news from around the world. Until then, and as always, I'm Matt Miller. Thanks for watching Talkin Science.